Now we need to talk about the rate at which this energy is converted to heat, light, and sound. And that is called power. That is a capital P for power. Schumann, what is the equation for power? What is the equation for power that we know rather than reading from the book? Rather than reading from the book, what is the equation we know for power? Because we're going to derive the equation for electrical power from the equation we know from power, rather than just reading it from the textbook. Help her out. Who knows the equation for power? Jay. Work over time. Power equals work over the change in time. In this particular case, the work that's being done on the electrons is actually the electric potential energy. So the work that's being done on the electrons is the change in the electric potential energy of the electrons. As we just went through, the electrons gain electric potential energy. We also happen to know that the electric potential difference equals the change in the electric potential energy per unit charge. We can rearrange this equation to get charge times the electric potential difference is equal to the change in the electric potential energy. In other words, we could substitute into this equation for power, we could substitute in Q times the electric potential difference for the change in the electric potential energy. So we have the charge multiplied by the electric potential difference divided by delta T. Well, we also know that charge over time is current. In other words, power is equal to current times electric potential difference. We also have this other equation for electric potential difference, which is it's equal to current times resistance. So we can substitute into this equation for electric potential difference, current times resistance. So we have current times resistance, which is equal to current squared times resistance. We can rearrange this equation to solve for current. Current is equal to the electric potential difference divided by the resistance. In other words, we can substitute in for current, electric potential difference divided by resistance. We get power equals electric potential difference over resistance, that quantity squared multiplied by resistance, or electric potential difference squared divided by resistance squared. And one of our resistances cancels out, and we get electric potential difference squared divided by the resistance. In other words, we have derived three different equations for power. Power equals current times electric potential difference, power equals current squared times resistance, and power equals electric potential difference squared divided by resistance. We have these three different equations for power. I'm going to combine them all here in one equation. Power is equal to current times electric potential difference. It is also equal to current squared times resistance, and it's also equal to the electric potential difference squared divided by the resistance. And that is what we're going to box. To review what I just did, all I did was combine the equation for power and the equation for electric potential difference equaling current times resistance to give us three different equations for electric power. And it all just depends on which two out of the three you have or are trying to find: current, electric potential difference, and resistance. What are the dimensions for power? Dimensions for power. Knickerbocker.
Watts.
Watts. What is a watt? Fry time. It's easiest to see if you look at this equation. Or this equation. Either one will give it to you. Joules per second. A watt is a joule per second. So we have something called, for example, a 100 watt light bulb. So a 100 watt light bulb literally converts 100 joules of energy every second, 100 joules of electric potential energy every second into heat, light, and sound. That is what a 100-watt light bulb means. Joules per second, power, is the rate at which energy is converted to other types of energy. So in this particular case, we're converting electric potential energy to heat, light, and sound.